Already in the last video we have seen what is normalization. If you did not, you please watch that video. This is normalization. Now normal forms 1NF, 2NF, 3NF, BCNF and 4NF we will see. First 1NF, which is nothing but a first normal form. A relation is said to be 1NF if it doesn't contain atomic values. Atomic means an attribute of a table cannot hold multiple values, which is nothing but an attribute of a value must consist single values only. It doesn't hold multiple values. That is nothing but atomic. Atomic means single, you can say. So here, for example, in you consider this table, roll number, name and course. For example, roll number 1, Ravi joined for some courses like C and C++. In some institute, he has joined for 2 courses, C and C++. Raju joined for C and C, Java and C. Sita joined for dbms. Now, if you observe here, this attribute is holding multiple values, not atomic values. So here, this table is not in 1NF. To convert this table into 1NF, I am using like this: rule number, name, course. Whatever the attributes are there, that as it is you need to mention. Next, rule number 1, Ravi, he joined for the course C, and again you need to mention rule number 1, Ravi joined for the course C++ also. 2, Raju Java, 2, Raju C, 3, Sita dbms. Now this table is 1NF. Why? Because each and every attribute is holding the single value, atomic values. Now we will see 2NF. A relation is said to be 2NF if it is in 1NF. It must be in 1NF also, and also no partial dependencies. So here, what do you mean by partial dependency? Means every non-key attribute fully depends on the primary key of the relation. So here, non-key attribute fully depends on the primary key attribute. We will see with example. First you should understand what is the fully dependence, partial dependence, what is prime key attribute, non-key attributes. By seeing that, you can understand easily this 2NF. Just you see functional dependency, all this terminologies we see. Terminologies related to normalization. So here, these are the terminologies we use in the normalization techniques. First, functional dependency. An association between two attributes of the same relation. For example, X determines Y. So here X is determining Y means X is nothing but a key attribute. Key attribute determines a non-key attribute. Then you can say that that is a functional dependent, or you can say it as a dependency. For example, rule number will be the key attribute. Why? Because rule number is always unique. Okay, so here rule number is the key attribute. Name is non-key attribute. Why? Because name may be repeats. Marks may also repeat. So here these all name and marks are the non-key attributes. Rule number is the key attribute here. By using this rule number, you can identify easily student names. By using this rule number, you can identify the marks of a student. So rule number 3 got 8 marks and so on. By using this rule number attribute, you can identify name and marks of the student. So here, this is nothing but a key attribute. These are nothing but a non-key attributes. Key attribute determines the non-key attributes. Or you can say that non-key attributes fully depending on the key attribute. Okay. So here this is nothing but a functional dependency, or you can call it as a dependency. So here, whenever the key attribute determines a non-key attribute, then you can say that that is a functional dependency. Now we will see partial dependency. Partial dependency means non-key attributes depends on the part of the primary key. So here, part of primary key determines the non-key attribute. Then you can say that that is a partial dependency. For example, by seeing the table you can come to know. For example, this is the table. Consider. So here rule number 1 in the subject ID 5 got 80 marks and student name is Ravi and 5 subject code means C course and teacher is Steven. And rule number 1 Ravi joined for the course 10 also. Okay, for example, in some institution he joined for the C and C++ and also he joined for the Java. So here rule number 1, subject ID 5, 10, 20. C, C++, Java courses joined. Rule number 2, some C++ course and also C course joined. Rule number 3, joined for only Java course. So here, if you observe here, rule by using rule number, you cannot identify the subject course in which subject he has joined. For example, rule number 1 is joined for multiple courses like C and C++ and Java. By using rule number, you cannot identify the subject name. Why? Because rule number 1 is having C and C++ and Java. Rule number 1 is having C, C++, Java. You cannot identify alone. Okay, one is joined for C, C++ or Java. Like that you cannot. So here rule number cannot determines which course he has joined. Okay, rule number 2 has joined for C++ and C. So alone rule number cannot determine the subject name. Okay, so here